Hi, my name is Jongnam. I'm a lead solutions architect of the AWS Well-Architected team managing Analytics Lens program. I'm here to present you to how to utilize AWS Well-Architected Analytics Lens to review your analytics workload. Who should watch this session? This session is for data architects who design analytics system for their teams or their company. The key takeaway of this session is that well-architected analytics lens will be reducing your time it takes to design your analytics systems. It is because AWS gathered customer-proven best practices across the company and customers into the analytics lens for you. So our journey started with this question: how can we ensure your workload is well designed according to well-architected design principles? We have AWS Well-Architected Framework already in place, which gives you all the design principles or questions along with best practices. And then we categorized into the 5 pillars for easier understanding, which is security, reliability, performance efficiency, cost optimizations, and operational excellence. In addition to this one, we also made a well-architected analytics lens. That is another set of questions and best practices for your analytics workload reviews. This is clarifications of the well-architected framework questions. So it will give you the X-ray view of your analytics workload. Let me start with the essence of the analytics workload. Analytics system is a data hub for your other systems. So this start with the data lifecycle. The system should support the lifecycle of the data within your company or within your team. So data be created into the online system as a first place. So I named it as a source zone for simplicity. Then online systems consume the data by themselves before sharing the data to someone else. Then here comes the data analytics system comes in play. So you as a data architect, you will need to move the source system data into a data lake using real-time ETL or batch ETL according to your business requirement. And then you will put that into landing zone. In this case, I named it as a structured data set. Once data arrived into the data lake, you will also want to curate the data because data set, you probably want to combine those customer data set into other source systems such as Salesforce customer data. So you need to combine and then massage the data so that it can be more easy to consume. And then finally, the data is curated. Then you can use your own analytics tools or machine learning tools to consume the data set for your analytics. Many cases, that curated data set and structured data set also will be shared to your colleague team or neighbor team for their own data analytics, along with their own raw data set. Finally, according to data lifecycle policy of your company, you will need to archive and delete your data set from the data lake. And then you will also need to do the same thing for our downstream systems. Analytics workload architecture is a little bit complicated, but let me try to make it as simple as possible. So you will have source system, which will be DynamoDB or RDS, many other storage systems. And then you will use movement technology such as Kinesis for real-time streaming or EMR for batch style data ingestions. And then you will consolidate the data source system into the data lake, central data lake. then use the multiple technologies such as Athena or Redshift for data analytics. On top of that, you will also need to ensure that your data set is protected according to security and compliance manner. And then you also need to manage other aspects such as budgeting or operational excellence monitoring, etc. So where should we begin? That is the questions to start with. So to do that, let's design an analytics workload for our team in this session as an example. This is the sample architecture that I prepared for you. So let's say customer, your team, your colleague team have a online systems which holds the raw data set into the S3 raw data. Or, maybe you can also save the data into on-premise databases as well. The first thing to consider when designing the system is security. So key question to ask is how to protect the workload. That is the key questions. Number one design principles, according to Analytics Lens, is you need to retain the least privilege for source access because the source system is owned by other team in most cases. So you need to ensure you understand the permission requirement of the source systems. You request least privilege to the source systems and establish emergency access process to the source and analytics system just in case of the emergency event. And then you will need to periodically review the privileges, ensure there's no any privilege access still there, even though it's no longer needed. So according to that principles, what that means is you may thinking about the raw data set S3 bucket, which will be owned by source system architect, you may ask them to allow read access to that bucket from your analytics system AWS account. So this is an example. You will ask them, source system architect, to put this IAM policy into their S3 bucket so that your system's analytics system can have read access to source systems S3 bucket. Once the bucket is established, then you will be ready to establish the AWS ETL process. In this case, AWS Glue ETL jobs. And then you also need to configure the read-only access be allowed to the AWS Glue ETL jobs within your AWS systems. Once the privilege is established, you need to thinking about the data classifications. How do you classify data in your analytics workload? It is because the source data is owned by source system owners. You need to know who are the owners of the data set. Then you will need to understand data classifications into the source system, such as is this containing sensitive data, such as personal information, or is this data should be regulated by other regulatory regions, such as SOX. Then you need to implement that data protection and lifecycle controls into the analytics workload. Finally, you will also need to demand your downstream systems also honor the data classifications. What that means in this diagram is once you have this data consumed by your ETL glue jobs, then you will copy the data into your data lake, which is, I named it as a landing zone. So you will convert the unstructured data from source systems such as JSON into structured format. In this case, this is a CSV file. And then according to data classifications, let's assume that business requirement is to archive into the Glacier 90 days and then delete the data after 10 years. So you will need to configure your own S3 bucket landing zone S3 bucket to automatically archive into the Glacier after 90 days, and then delete after 10 years as an S3 lifecycle policy. Then S3 will automatically honor the policy and then move into the Glacier and permanently delete after 10 years according to your requirement. You need to grant least privilege to the analytics users. The first principle was about you need to request least privilege to the source systems. This design principle is you need to only give a very minimal privilege to your users, which will be data analysts, or downstream system owners. So you need to implement permission controls for each attack surface, which could be storage layer such as S3, or SQL layer such as Redshift, or application layer such as QuickSight. Then you should implement AWS account level permission guardrails, such as you may distinguish between S3 bucket, data lake bucket from the analytics system AWS account, so that you ensure the data lake account only holds the data set without any other users. What that means in the diagram is that once we have this one, then let's focus on the landing zone S3 bucket, which holds the CSV data. What that means is you will also allow read-only access against that landing zone S3 bucket that allows access by analytics account in this case. You will create the AWS Glue crawler to collect the metadata or data dictionary and then consolidate it into central data catalog, which is AWS Glue data catalog in this case. Once the catalog and the structured data set is ready, then analytics zone, your system will provision any analytics tool such as Athena, Redshift, QuickSight, or even SageMaker, and then you will let your users, data architect, engineers, analysts, or scientists to consume the data set and then perform the business analytics jobs. Next pillar about the analytics lens is reliability. How can you build resilient analytics pipelines? That is the key question to consider. So as a number 4 design principle, you need to design the resiliency for analytics pipelines. What that means is you should understand business requirements of the ETL job, such as how often the data should be pumped into the data lake, or how fast it should be done within a day, etc. Then you need to monitor analytics systems to detect ETL job failures. Quite often you will see ETL job fail for various reasons, such as maybe ETL cluster might be terminated for some reason. Maybe data has some anomaly inside a data set. So you need to monitor such system anomalies as part of your monitoring. Then once you understand the data anomaly or analytics system failures, you need to notify source analytics and downstream workload about such ETL failures so that they can cope with the recovery. So finally, you will need to automate this recovery of the ETL job failures. So let's come back to this diagram. So what that means is we'll focus on ETL glue jobs. Let's assume that this ETL job failed. Then AWS Glue ETL job has a feature to notify such a failure event into the AWS CloudWatch event. What that means, what the design principle means in this architecture is you will consume that CloudWatch event failure signal using SNS, and then you will notify to the users, such as analytics architects, engineers, analysts, and scientists. Finally, you will also want to automate the recovery. In this case, you will subscribe to that sentence topic using AWS Lambda. You will create brand new script using Lambda code, and then that Lambda function will restart the ETL command based upon your business requirement. That's what that means, number 4, design principle. Design principle number 5 is about the data change governance. How do you govern the data changes? It is important because if you don't control the data changes down the line, that such an impact will be much harder to catch by the downstream systems. You want to catch such data changes upfront and then copy that in advance. So please understand your business requirements, such as delivery and SLAs, how often the data should be delivered to the data lake on what time. And then you need to monitor data quality anomalies, such as there will be some field that you expect always present. So you want to ensure that such assumption always be met. The next one is you need to define your own standard operating procedures or SOPs, such as data backfillings, so that your operations team, DevOps team, can follow the standard operating procedures to manage the data changes accordingly. Finally, also you need to think about the automations, that data change propagations. So let's come back to the architectures. So in this diagram, what that means is, let's assume that the AWS Glue job notifies the success signal. Glue job has a feature to notify to the CloudWatch event about the success and failures. So in this case, let's focus on success signals. So CloudWatch event catched the success signal, and then AWS Glue ETL job successfully transformed the data from source systems to the landing zone CSV file. What you need to do, or what you need to consider is, you need to consider to monitoring the new data set arriving into the landing zone, and then trigger AWS Glue ETL job or any other query processing jobs to check the data qualities, such as there should be certain fields, such as custom ID, always should be present, or there should be any sensitive data exist inside the data set, etc. You will double check that such data quality whenever the new data set arrives. Then, so data backfill command is another way to check. If the data quality is failed, you will need to thinking about how to backfill the data. If the data set is okay to backfill using yesterday's data, then please go ahead. You need to think about the automations of such SOP procedures. Next pillar is about the performance. How can you optimize your analytics performance and your ETL performance? That is the key question to consider. As in design principle number 6, you need to choose the optimal file format and partitioning. So please ask yourself, how do you select the best performing file formats and partitioning? So you should select format based on data update patterns, such as certain data set will be only append only, or such data set will be updated in place. Next one is please select your data format, file format based upon data read patterns, such as you may know that most of the cases your analytics job is about the select, where, group by, etc. So you will catch which column or which attribute be in place inside the where and group by clause. And then use the file compression to improve I/O efficiency and partition the data to avoid unnecessary file reads. So what that means in the diagram is like this way. So let's focus on the landing zone. So let's assume that the CS file is too small. There are so many little files. So you may want to think about the curation. So in this case, Parquet file is partitioned by date. So a new data bucket, S3 bucket is prepared. And then let's delete the S3 glacier in this diagram for a simplicity. You will need to think about the another data curation, which is Amazon EMR in this case. And then you will think about the running the data movement between landing zone into the curation zone every hour. So that is the point. And then you will collect the metadata again so that analytics processors can understand the curation zone S3 bucket and then use the data analytics job. Again, analytics zone or analytics jobs can access to both landing zone and curation zone at the same time. So they can do ad hoc queries, they can do reporting queries, etc. Design principle number 7 is about choosing the optimal storage solutions. So please ask yourself, how do you select the best storage options for your workload? You should understand your storage I/O demands and characteristics for each workload component, evaluate available configuration options, and make decisions based on access patterns, data growth, and metrics. So coming back to the architecture diagram, what that means is let's focus on Amazon Redshift as an example. You may need to consider using Amazon Spectrum tables instead of loading all the data set into the Amazon Redshift local storage. And then you may need to think about the materialized views just for performance efficiency. Going to the Amazon QuickSight, what that means is you can think about the SPICE in-memory storage as a storage instead of directly calling the Amazon Athena or S3 from the QuickSight for better performance. If you use Amazon SageMaker, in this case, you may think about the NVMe SSD volume for faster performance. So that's it. So next design principle is choosing the optimal compute solutions. So please follow the business requirements for ETL and analytics processing, such as is your business needs the real-time processing, or is it okay for your business to process the data on a daily basis? Then evaluate the available ETL and analytics options. Use the available elasticity of the resources, such as EMR auto-scaling. Reevaluate compute needs based on metrics. You don't need to stick to the static configuration all the time because AWS give you the flexibility. You can change your compute options anytime. Finally, use the AWS managed services for less operational burden. Your team is limited resources. Your time is limited resources. Please ensure you leverage all the managed resources such as Lambda or Amazon Athena or Redshift, and then reduce your operational burden, and then so that your team can focus on more business value added jobs. What I mean in the diagram is, let's assume that the business requirement has been changed. That our business owners wants to see the real-time analytics jobs. In this diagram, there's no such component to support the real-time processing. So what we want to do is we will introduce brand new movement zone, which will be processing incoming data set in real time using Kinesis, pump it into a source zone so that the existing batch processors can do the job. Amazon Kinesis, take the data, and then move it into Elasticsearch service for real-time processing, operational processing. Next pillar is cost optimizations, how to govern the cost. So please delete out of use data. Follow your business requirement. What is the data retention as a first place? Certain regulation may require us to delete the data after 10 years or 5 years. So you need to understand that one first. And then once you have the data, please delete the data as long as you don't need that. And then many cases you will have an intermittent data set that you generated as part of the data curation. If that data is not necessary, please delete immediately so that you can save the storage cost. And then consider automation of the data deletion and then notify such data deletion event to the older stakeholders. In the diagram, let's focus on Amazon Redshift. What that means is you will think about using Amazon Redshift vacuum delete command to delete unused storage. Going back to landing zone, you may think about another Amazon Lifecycle policy to delete in 14 days because the landing zone only holds the temporary data, and then in the diagram, the older data set is managed by curation zone. So going to the curation zone, you may think about the delete in a year, assuming your business only needs up to the 1 year data set into the data lake. Finally, according to the data regulations, you may think about the enforcing, retaining, or deleting the raw data set after 10 years from source systems. Next design principle is always choose the lowest cost storage solutions. Decouple. The number one is you please consider decoupling storage from compute so that you can have more flexibility, and then gather the metrics or data set to understand the data read and write patterns, and then automate the best metrics-based storage configuration changes. In the diagram, what that means is coming to the Redshift, you may think about the changing your compute type, node type into the RA3, which decouples compute from storage so that you can independently scale out or scale in the compute node and then storage sizes. Curation zones, S3 bucket, you may think about the intelligent tiering, because intelligent tiering automatically understand the read patterns and then move into cheaper storage options for you. Amazon EMR in this curation zone, you may think about Amazon EMR FS instead of copying data from landing zone into Amazon EMR local clusters. So that is example. Then next design principle is always choose the lowest compute solutions. So perform the cost modeling, and then you need to think about the automations of the resource type selection based upon configurations, and then perform the pricing model analytics. And please think about using the other billing mechanisms such as on-demand, reserved, or spot instances. In the architecture diagram, what I mean is you may think about the Redshift. Most cases, Redshift just are running 24 hours. So you can think about using Amazon Redshift reserved instances to save the cost. Going to the Amazon EMR, also you can think about spot instance, because EMR doesn't need to be run 24/7, and then this is okay to be interrupted, and then you can just restart the EMR cluster one more time, even if the spot instance has been terminated. One last thing is maybe you can think about the changing the duration of the EMR clusters. Maybe your business only needs a data set on a weekly basis. In this case, you can change the duration from hour to weekly so that you can reduce the compute time. So it will save the cost entirely. Final pillar is operational excellence. How can you maintain the operational good health? So please monitor the health of the analytics pipelines so that you can monitor planned arrival of the recent data from the source systems. They validate the data quality of the source system before moving to the analytics. And then monitor and measure the execution schedules of the recurring analytics jobs. Probably you need to monitor daily ETL jobs to arrive before 7 a.m. as an example. And then define the measure the runtime durations of the analytics jobs. You don't expect the daily job to be complete after 24 hours. So you need to understand the SLA of the data completions. What that means in the architecture is there's no mechanism in the architecture diagram as of now. So as an example, you may think about the putting Amazon CloudWatch dashboard and then share the data dashboard to all the people, including source system architects, analytics architects, and then engineers, scientists, and analysts, so that all of them can watch the dashboard and see whether the data is arriving in a healthier manner. Okay, so takeaway. Please use the analytics lens for your well-architected design for your workload. It will save your time much. So wrapping up the analytics lens, we have design principles. So you can see that there are 12 design principles, but we also continuously revising the design principles and best practices along with customer experiences. Wrapping up, please go to AWS Well-Architected Analytics Lens so you can see the tailored best practices for your analytics workload in the AWS cloud. Another useful resources are AWS Well-Architected Framework, Well-Architected Labs, where you can go ahead and do the hands-on testing and then education by yourself. And we have an AWS Architecture Center, and then AWS Solutions Library is the place where you can see all the reference implementations. Thank you. Thanks for your time. And then please reach me out for this email and the Twitter. And then please complete the session survey and then enjoy the rest of the re:Invent events. Thank you.